Hello, and thank you for joining us this afternoon. The Office of Research and Innovation's mission is to foster the advancement of cutting-edge research discoveries and technology at the University of Texas at Dallas. With our departmental resources, we provide faculty, staff, and students with a variety of specialized information and training to help efficiently navigate funding opportunities. During today's National Science Foundation Career Spotlight Series, Dr. Simon Dye will share his enthusiasm for research and explaining how the NSF Career Award provides the foundation for a lifetime of leadership in integrating education and research. I am Tiffany Willoughby, Research Education Programs and Outreach Assistant Director in the Office of Research and Innovation at the University of Texas at Dallas. I will serve as a session moderator. Joining me today is Dr. Simon Dye. Dr. Simon Dye is an assistant professor of mechanical engineering at the University of Texas at Dallas. He is a recipient of the National Science Foundation Career Award in 2021 and the Army Research Office Young Investigator Award in 2019. He also received the Outstanding Early Career Award at the 2021 Microflow and Interfacial Phenomena Conference for outstanding and significant contributions to the fields of surface wettability, phase change heat transfer, and water harvesting. His students won the first place award in the departmental poster competition in 2021, the ASME Best Poster Award in Micro and Nanotechnology in 2019, and the first place award in the STEM Bridge Summer Program in 2018. Dr. Dye earned his PhD degree at the University of South Carolina and his Master's of Science and Bachelor's of Science degrees at Huazhong University of Science and Technology and Chongqing University. His research interests include bio-inspired materials, wetting, and thermal fluid with applications in water, energy, and health. Welcome, Dr. Dye.
Yes. Thank you, Tiffany, for your kind invitation and introduction. So let me share my screen. All right. Yeah, thank you again, Tiffany. So when Tiffany approached me last year, there were multiple available time slots. And I intentionally chose March this year because I think today is the time for you to start. Not necessarily start writing your proposal, but at least start thinking about your ideas. The deadline for this year is July 25th. So I suggest you complete your first version 1 or 2 months before the deadline, which is May 25th. And you leave 1 or 2 months to get comments and improve your writing. And today's title is Individual Contributor in the Community Wins a Career Award. And this is a conclusion from myself. I'm going to use this presentation to justify why individual contributor in a community is very important. So the presentation includes 2 parts. In the first section, I'm going to share my understanding of career, and in the second section, I will share my experience in applying for career. Now, when we start a project in my group, we typically begin with the end in mind. So when we write an NSF career proposal, I'd like to know what's the end. And this is a statement from the NSF Career website. It states, NSF Career funds the potential role models to help them build a firm foundation for a lifetime of leadership in integrating education and research. We all know NSF Career is a project, it's a grant. But if you read this statement, it sounds like it's funding a person. So the immediate question from me will be, does NSF Career fund a project or a person? Now, if you look at some keywords, the potential role models, a lifetime of leadership, integrating education and research. When we look at the leadership and role models, they sound like a person. So what does that mean? When we talk about the leadership, let me give one example. So if you develop a project and this project create a new area in your field, you actually become a leader of that field. And you become a leader because you have that project. And you will be other faculties, either young faculty or even senior faculty's role model. So from that sense, I would say NSF CAREER found a person with an excellent project. And this person could potentially be a leader. And this project is to help the person to be a leader in the field. That's my understanding. And that's why I put the bottom sentence. Individual contributor in a community wins a career award. Now, what does the individual contributor mean? I'll give you two examples. So imagine that you have an expertise, you have students, you have postdocs, you have facilities in your group. So that's what you have. And you have two choices, not only two, but I give those two as examples. You can choose to develop some new expertise in your group because in order to be a leader in your field, you need that expertise. For example, you may be working on, for example, heat transfer. You work on heat transfer and you may need a new material. You can choose to develop that material in your group and use that material for your heat transfer study. Then the heat transfer people will think you are a leader because you have a very unique material. But you can also have another choice. You are working on heat transfer and you need a material. You can collaborate with an expert to make that material. Either way will be okay. And sometimes you are working on computation, but you may need experiments to generate preliminary results. That's also typical. You can choose to collaborate with an expert to provide you experimental data. So you use those data for your computation study. But you can also develop the experiment expertise in your group. You don't need to be an expert in experiments, but at least you can generate some preliminary results. So there are two mindsets. And individual contributor means you need to develop expertise in your group. That's highly preferred. In very few cases, you may be able to request a letter of support from your collaborator to provide minor support. But most likely, reviewers want you to develop everything in your group. So you can be a leader in your field, and you can be a role model for junior faculties in your field. Now, when we become a faculty now, and we talk to colleagues in the department, you may hear a lot of collaboration. And keep in mind, you are at a different career stage from your colleagues. By the way, when you see this small career, that means your career, and the capital career is a career award. If you collaborate with your colleague, your colleague collaborate with you, that's good. I think it's encouraged, but the target will not be NSF Career Award because NSF Career Award does not need a KPI. Actually, you cannot have a KPI. You can have a letter of support with minor support. The majority or almost everything should be in the proposal. You can do it with your preliminary results or your group's expertise. So it's okay to collaborate and actually it's encouraged. But for this particular award, NSF Career Award, you need to be an individual contributor without a lot of collaborations. Now, who determines if your career award is funded or not? Again, when you see the capital career, that means NSF Career Award. When you see the small career, that means your own career. The answer is your career plan determines your career award is funded or not. So typically, when we see other colleagues win the career award, we are proud of them. And in the meantime, we want to be part of them. So we want a career award. I also want a career award. That's usual, but that's not enough. Typically, you need to think a further step. So think about leadership. That's what NSF Career wants to see. So if you think about leadership, you want to be a leader in your field. You want to be a contributor in your field. Then you make a plan for your next 5 or 10 years to be that leader. And you make a career plan. That career plan needs a career award to support your project, to support your personal career. And if you think in that way, and develop your expertise and project, very likely your community tends to give you the NSF Career Award. So here is the balance. I want a career, and my career plan needs a career. They are actually very different when you actually start writing a proposal. Those are two different mindsets. And I would encourage you to think about what you can contribute to your community and how to be a leader in your community, because your community needs a future, and your community future is in the junior faculty's hand. It's not in the senior faculty's hand. That's why when the senior faculty in your community evaluate the proposals, they want to support the leader or the potential leaders in the field, because those leaders will give the future of your community. That's why I encourage you to think about your community and make a career plan, and you will very likely get the career award. Again, begin with the end in mind. So when we are PhD student, a postdoc, we were quite familiar with the paper and the journal. When we work with a paper, we want to submit to a journal. And when we work with a paper, we don't necessarily to solve a problem. For example, when people make sandwich, they use turkey, and you make a new sandwich with chicken or with beef. It can be a paper, but what problems did that solve? Actually, no problems. We can simply change turkey to chicken or beef or even pork. We did not solve any problems. We can publish a paper because it's quite different from the sandwich with turkey, but it's not a project. The good project needs to solve a problem. And this problem should be a scientific problem or engineering problem. We develop a project to solve that. So those could be clear in our mind, but the bottom may not be very clear. When I became a faculty, I was not quite familiar with different funding agencies. Why do we need different funding agencies? The NSF DOD, DOE, NIH. Those may not be very clear to everyone, in particular for the junior faculty. But if we are familiar with different funding agencies, then we need to understand NSF. So NSF tends to fund transformative research. Transformative research is not equal to fundamental research, but fundamental research are typically transformative. That's why when we talk about NSF, our immediate response will be you need fundamentals. Now, we are talking about NSF CAREER. NSF CAREER is a little different from regular NSF project. First, it's a 5-year project. A regular project is 3 years. Second, it's an award. It's a project, but it's also an award. That's why NSF states they tend to find a leader in the field. And finally, you want to identify the program in the NSF. There are different programs. Which program is the best for you? Or you can ask which community would like your idea or would like your research. Those should be clear in your mind if it's not clear right now. There are some prestigious early career awards. NSF has career, DoD, including Army, Air Force, and Navy. They also have their Young Investigator program. DARPA, NASA, and the DOE also have the early career awards. I highlight them in blue colors because they have specific topics every year. That means you can't think about a problem for them. They have their problems. They just need your solutions. NIH has the NIH Director's New Innovator Award. We typically call them DP2. This is the NIH-wide Young Investigator Award, and it's very prestigious as well. So if you look at those different early career awards, NSF CAREER is probably the only one that everyone can apply if you choose to apply. Some of them may not care NSF CAREER Award because they may like NIH. That's a lot of money. But if they choose to apply, they can find a program. For the others, you may not be able to find your program. That's why they are a little bit different. So from this sense, the NSF CAREER Award is an award that every young investigator can apply if they choose to apply. If they give up, that's a different story. That's why it's a very prestigious award to identify successful young faculty in different areas. It's not a criteria, but we talked about that a lot. I think that's part of the reason. Now I'm going to stop. In case you have any questions, I can answer them. So by the way, I'll stop at around 15 minutes, 30 minutes, and the end of the presentation to answer some questions.
And Dr. Dai, at this time, we don't have any questions in the queue, but audience, as Dr. Dai notes, we are happy to receive them and answer them in the order that you present. Thank you.
Thank you, Tiffany. So I'll go ahead. If you have any question, feel free to send your question and I answer them at 30 minutes or at the end of the presentation. Let's begin with the end in mind. In order to win the NSF CAREER Award, I put it as a function. So we are either from science or an engineer. We know the equation. F is a function, and in this function we have some parameters A, B, C, D, E, F, G, HI. So A is the program manager who is handling your proposal. B, reviewers who are reviewing your proposal. C is your idea. D is your proposal. I put the idea and the proposal separately for a reason. I'm going to explain that later. E is your idea, no, your area, sorry. So E is your area, your research area or your community. This seems to be easy for most faculty, but not easy for some of them because they found it's very hard to identify their program in NSF. Now, F is your previous advisors that may influence your proposal positively or negatively. That's something you can't change. That's why I put them in gray colors. G is your competitors. You can't control that. H, there may be some politics. I, you may need good luck. So F, G, H, I are in gray colors because you can't control them. You can't change them. However, you can think about A, B, C, D, E. Now, let me explain them one by one. A is a program manager. Program manager is the person who will handle your proposal. The program manager will find the reviewers for your proposal. And the program manager will make the final recommendation to the division director whether the program would like to fund your proposal or not. By the way, program manager makes recommendation. It's not a decision. Now, in order to help the program manager understand your research so he or she can have confidence on you, you can do a few things. The VPR's office will organize a DC trip, and I attended that. That was very helpful. So you will have the opportunity to communicate with the program manager at DC. After COVID, I think we're going to have that, and I encourage you to take that opportunity. With that, you can go to DC, meet your program manager, talk to them, and you can also visit other program managers such as DoD, ONR, other DoD funding agencies. When you meet with the program manager, you don't need to tell them what you have done in your group. You need to tell them a problem and a solution. So bring the problems, scientific problems you want to solve, and your preliminary results, the expertise in your group that can help you to solve the problem. That's important. When I was interacting with a program manager in the very beginning, I was trying to sell the research achievements in our group. They are not interested in your achievements. They want to know the problem. The problem should be relevant to their program and your preliminary results or your solutions. They are interested in those. You can also invite your program manager to visit UTD. When I was interacting with a program manager, I didn't realize actually the NSF program manager has two different types. The first type is a permanent manager. That's their job, to stay at NSF. But there was another type we call rotator. So typically a faculty in your area join NSF as a program manager to help the community after maybe 3 or 5 years, they need to find their jobs. So if you invite them to UTD, maybe they will be interested in joining UTD in the future. And they would probably say yes. So if you can invite a program manager to visit UTD and your lab, they will understand your research, understand the campus facilities, and they may have more confidence on you if you apply the NSF Career Award. That's actually important because sometimes 4 or 5 proposals rank the same. Then which one to choose? The program manager has the flexibility. If they like your project and have confidence on you, in that case, there may be some advantages. B, reviewers. So the first thing you can do is to volunteer in an NSF review panel. With that, you can understand how your proposal is going to be reviewed in a panel and understand the areas of the reviewers. The reviewers are from different areas. Even you work on the same topic, but they're very different subjects in that topic. So this will help you to write your proposal, because when you write your paper, the paper will be reviewed internationally. The editor can find an expert for sure to review your paper. But in a panel, it's likely the program manager could not find 4 experts in your field in the same panel. Very likely, no. That means your proposal will be reviewed by experts and non-experts in your area, in your specific area. You need to go to the panel and understand that better, and choose your program. If not, sometimes we may think my advisor is in this program. My advisor won the award in this program. I should be in this program. But that may not be correct with your specific project, because typically we had the postdoc experience, PhD, we tend to combine them together, and sometimes we may belong to the postdoc program or may belong to the PhD program, and they are different. So it's actually uncertain. If you go to the panel, you understand the reviewers, understand the panel, then you may choose the right program. And finally, if you understand the reviewers in your program, then you can make your proposal easy to understand. This is very different from writing a paper. As we mentioned, a paper will be reviewed by an expert, because the paper reviewers are from the world, but the proposal reviewers are from the United States. Very likely, your proposal will be reviewed by some experts, but also non-experts in your specific area. And C is your idea. When we talk about idea, it actually includes 3 parts at least. First is a problem you want to solve. Second, your approach to solve that problem. Third, your approach must be novel. And when we talk about the problem, it's actually the scientific problem. For example, we can't just say we want to improve the energy efficiency. That's not a problem for proposal. That's a very general problem. The problem needs to meet a SMART principle. S is a specific, M measurable, A is achievable, R is relevant, and T is time bound. So specific, basically you need a specific scientific problem in your project. Measurable is you need to identify whether your project meets the successful or not. For example, you want to increase the efficiency, by say 500%, sometimes like that, as you have some quantitative results, quantitative goal to measure your success. Achievable, you need to take some risk for sure, otherwise the novelty will be limited. But in the meantime, you need to achieve it in 5 years. And this is also relevant to T. T is time bound. So achievable in 5 years. Relevant, it must be relevant to the program you are going to submit. This is actually not very easy. I know some faculty have a hard time to find their program. When they submit to different programs, the reviewers in those programs are not interested in the proposal. So relevant is actually very important. Now, when you have a problem, this problem is typically a common problem in your field. That means not everyone, but most people, at least the experts, know the problem. They just can't solve it because they don't have the right approach or they don't have an innovative approach. Personally, I think the problem should be a common problem in your field, but hard problem. I'm not sure if you can if you can identify a new problem that nobody else is even aware of that problem, because that may be too risky when reviewers review your project. So you need some balance. Approach. Now, assuming you identified a problem that experts in your field would agree that's a tough problem, and if you can solve that, you can be a leader in this field. Then very likely you need an innovative approach. And this approach will help you to build your leadership in the field, because this is a common and tough problem nobody can solve in your field. You can, because you have this unique approach. And that's why you can be a leader in your field, because you are innovative. You can create a new approach to find a future for your area. The senior faculty would appreciate that. And when they review your proposal, they tend to fund your proposal. And if you that kind of you have that kind of approach, it's innovative for sure. Novelty is there. I think those are very important. You don't need to wait until your proposal is completed. You can actually start with 5-page slides, seek advice, and answer the questions. Is this problem a tough and important problem? Is this approach innovative? Does my group have preliminary results and expertise to execute this approach? Because sometimes the problem and the approach are well known, just no one can execute that approach. and you show my group can, then that's a good project. You can start the writing process. D is your proposal. When you start writing your proposal, reviewers must understand your proposal. Reviewers will not fund a project they don't understand. Typically, there are maybe 4 or 5, at least 3. In my program, 4 reviewers. They need to understand your problem, approach, novelty, your group's expertise, and your preliminary results. They don't need to understand everything, but they need to understand the key points. And this is very different from a paper. I think we emphasize that. Let me give one example. On the right, you see heat transfer. So this is my area. And heat transfer has 3 subjects: conduction, convection, and radiation. Those are the 3, we can say 3 areas. Now, they all belong to the heat transfer program in NSF. We call thermal transport processes. I belong to convection. When I write a proposal relevant to convection, I need to submit to this heat transfer program. Unfortunately, it's very hard to find 4 reviewers in the same panel to review my proposal. That means experts in conduction and radiation will also be my reviewers. But they may not, very likely, they don't understand the fundamentals in convection or the cutting edge research in convection, because actually there are different areas. You need to let them understand your proposal. That means if you are in convection, you need to let convection experts understand your proposal. That's for sure. You also want the experts in conduction and radiation understand your key points of the proposal, not everything. And that's very different from a paper, because when I submit a paper, my paper belongs to convection and it's going to be reviewed by experts in convection. If the editor cannot find an expert in the United States, they can find an expert in Europe or in Asia, but they can find an expert for sure. Proposal is very different, and that determines how you write your proposal. Finally, your area. You need to identify the right program and submit your proposal. Check the prior funded proposals in that program. If you see no proposals, no funded proposals relevant to your project, very likely the reviewers will not be in your area. As I said, 4 reviewers will not fund a proposal that none of them can understand. It's like impossible. So that's very important as well. And I will stop to answer questions if there's any question.
Thank you, Dr. Dai. There is one question from the audience. They are interested to know what it takes to be an NSF reviewer. Can anyone apply to do that? Do you have to be a faculty member? Do you need any experience? If you could shed a little bit of light on that.
Yes, of course. So when I attended the NSF review panel, I saw postdocs, I saw junior faculty, senior faculty. So I would suggest you contact the program manager, send your CV, and tell them you are available and happy to be a volunteer in the review panel. Different program managers may have different preference. Some of them may give opportunity to postdoc to join the panel. Some of them may give opportunity to assistant professors, and some of them may like senior professors, such as associate professors or full professors. It depends. So I would suggest to contact the program manager. It does not hurt. Immediate them immediately. If you haven't done so, email them today. Send their CV, tell them you're available, and wait. Thank you.
I have another question, Dr. Dai, from the queue, and that is it smart to break up your proposal into sections? And if so, which section do you do first?
Tiffany, can you repeat the question? Two section? What does it mean by two section?
Breaking the proposal down into different parts. So for example, if someone was beginning to formulate their proposal, would they start on their broader impact plan first? What area would they start on first?
Okay, that's a very good question. So when we talk about intellectual merit and broad impacts, we think they are two separate parts, probably because broad impacts is quite relevant to education, but broad impact is also relevant to your research, because when you choose the idea, for example, you have 5 ideas, you can choose one of them to be your career proposal. One of them may be super fundamental. You can hardly find any application. Then the idea does not have broad impacts. You may, I don't know if that's a good idea, a good project for the NSF career. I'm in engineering, by the way. I think there may be some faculty from science. I tend to find an idea which has potential application, for very clear potential application. And I define that as a broad impact of this technical part. So I identify one of the 5 ideas based on broad impacts, then see which one can give the most innovative novelty. I'm not sure if that answers the questions, but I don't think we should think the intellectual merit and broad impact as two separate parts. They are integrated together. Thank you.
Thank you, Dr. Dai, and there are no further questions in the queue at this time.
All right, let's move forward. So once we are familiar with NSF and your program and the formula to win the NSF Career Award, you want to identify the gap as soon as possible, because you may understand NSF, your program, the panel quite well, but how about your own project? So I would say you may overestimate or underestimate your project. Why do I say that? Because this depends on your background. If you are from a very successful group, either in your postdoc or PhD, you may think, oh, my advisor get awards or grants pretty easy. It's not very hard. I wrote proposals for my advisor. It was successful immediately. I may do the same. This is the definition of overestimate. You are very different from your advisor because your advisor was successful and was well known in the field, but you are junior. Underestimate is like the other way. You may be from a university which is very different from MIT or Stanford, not very famous group and your advisor may find a hard time to win the award. And you may think, oh, I may not get the NSF Career Award. That's my definition of underestimate. I think you need a good understanding of your specific project or idea. Here I call it problem or approach. How to do that? Let the reviewers evaluate. Don't evaluate on your own because you may overestimate or underestimate your problem or approach. You need to let the reviewers in your program evaluate that. And that feedback will give you a better understanding. Sometimes you think this is a very good idea, but you get maybe 3 fail or even poor. That means it's not a good idea. You don't need to evaluate on your own. You just need to take action. So you can gain first-hand understanding. So definition of first understanding is you write your proposal and you get feedback from the reviewers. And you look at the reviewers' comments. That's my definition of first-hand understanding. You don't need to listen to others because that's second-hand understanding. And with that, you can understand the problem and the approach more fairly. And you can also understand your reviewers. Maybe you submitted to a wrong program. You need to change your program. So identify the gap as soon as possible and bridge the gap as soon as possible. So if you submit your proposal and get comments, I think you can choose your program. Choose the right program. And you may already submit to the right program. So you don't need to change. You stay in that program, submit again. And then you can volunteer in a review panel. So that's another way to bridge the gap. And choose the best idea. For example, you may have 3 good ideas and you are afraid because you have only 3 chances to submit your career proposal. So you submit a very good idea to a regular, to the same program as a regular proposal, and it's funded. It's good. I mean, congratulations. But as a program manager, they don't want to give all the money to one person, even though you are a star. They need to balance. If the 2 ideas, if you want a regular NSF grant from the program and you submit a completely different project, that may be another story. But if it's not completely different, it's actually relevant, then it's probably very hard to win the career award if the first funded project is not completed yet. So I would say submit the best idea as your career proposal. In particular, for your first submission, submit as soon as possible. On one hand, you may think that I only have 3 chances, but on the other hand, you have 3 chances. That's actually a lot. Use the first chance as soon as possible. At least that's what I did. That's important for multiple reasons. Number one, if you submit your first NSF career proposal, that means you have thought about your leadership in your community. You have identified, you have been trying to identify a program, and you don't need to worry, what if my proposal is funded? How can I get a career? Because you are submitting a career. I would say submit your first NSF career as soon as possible. For the second submission, you need to be careful. I'm going to talk about that based on my experience. And again, you have 3 chances. Wasting 1 chance. It's like a wasting, but it's not, because you did a lot of homework before your first submission, right? You won't submit your first NSF career proposal if you haven't identified your program, if you haven't attended the review panel. So that's why I say choose your program, volunteer in the review panel, and then submit your first NSF career proposal as soon as possible. Now, this is my personal experience. I'm going to catch up a little bit. The first thing I want to highlight is PhD. To be honest, I like my university, the University of South Carolina. It's a good university, but it's not as good as MIT, Stanford for sure. And the engineering program is not even as good as UTD. So I'm sharing this because I want to encourage everyone, if I can win the career award, in principle, every one of you can win the NSF career award, because I believe you graduate from a good university, or at least a better university than the University of South Carolina. You just need to find the right way to get it, and I believe you can, if you really want to win the NSF career award. The second thing I want to highlight is, in 2019, I won the Army Research Office Young Investigator Award. And why do I need to highlight that? It's not because I want to show off. It's because this award actually let reviewers have confidence on the PI, right? If you see a project, the PI win the Young Investigator Award, that means the community already think this PI is good, at least not bad. They will have more confidence on you. So I'm trying to say, if you can have something else to let your community understand your success. For example, I know people in my community chair a conference. That means, a lot of people will know him or her, and they know this PI is contributing to the community. He or she is an individual contributor, right? And he or she is active in the field. He or she published some good papers. They will have confidence on you. And if you have those opportunities, I think they will still help you to win the career award. This is timeline to show my submission. First, I joined UT Dallas in the summer of 2016. Then, in the first summer, which is 2017 summer, I immediately submitted my first NSF career proposal based on my postdoc research. I did this for multiple reasons. Some of the reasons I've mentioned, I identified the right program, I attended the panel, and there was successful awardee in my community. They submitted in their first year and they won the career award. So I tried that. It was rejected. That's good, but I was familiar with the entire process. Now, what I did wrong is the second submission. So when I received the reviewers' feedback in 2017, I thought I did not have enough preliminary results. And I did some preliminary works. and submit it again in the next year, which is 2018 summer. Actually, I shouldn't have done that, because now if I look back, in the first submission, the reviewers' comments was all about the idea, the key idea, not about the preliminary results. I interpret the reviewers' comments incorrectly. I should have changed the ideas and not submit in 2018. This is something you want to be careful as well, because you have only 2 chances after the first submission. So you want to identify whether you need to change the idea or you need more preliminary results. And that's case by case. How to identify that? It may not be easy. Don't be, it's not confidential. You want to share that with your colleagues and get feedback. They can help you to identify whether you need to change the idea or whether you can just get more preliminary results. In 2018 October, APR's office at UT Dallas organized the DC trip, and I attended that. I highly recommend you to do that. And you will meet with the program manager, talk about your problem and the approach in person. In 2019, probably because of this visit and the proposal, the second submission was rejected. So the program manager encouraged me to submit the NSF eager proposal. NSF eager is basically a separate proposal, 8 pages, and the program manager will communicate with you. That if they encourage you to submit, very likely you will get the award. So this is something relevant to the second submission, although it's rejected, but there is an NSF eager. In 2019, so our group won the Army Research Office Young Investigator Award based on an innovative paper we published. So the innovative paper, a good paper, can actually help you a lot. And then in 2020 summer, submitted the third submission of the NSF CAREER proposal. At that time, we completed the eager and we have an active ARO YIP award. I used the grant revision service recommended by Xianming. That helps a lot. They cannot provide very professional comments, but they saw a lot of proposals, so they know how to write a proposal. So they can give detailed revisions, such as English, organization, whether a paragraph is clear or not. They can give comments on that. And I sent the proposal to colleagues for feedback. It's very hard to get funded if your proposal is not reviewed by experts in your field before your submission, or if it's not reviewed by your colleagues. Nothing is confidential. Send your proposal to your colleagues for feedback. Don't worry if they are going to, scoop your idea and do it. No, more than 99%, that's not going to happen. They will help you. So send a proposal to colleagues for feedback. Finally, again, NSF CAREER finds the potential role models to help them build a firm foundation for a lifetime of leadership in integrating education and research. If you think for your future, that's good, you may succeed. But if you think for your community's future, you will succeed and be respected by your community. And more importantly, your community, your reviewers are in your community, they tend to give you an NSF Career Award. Thank you. That's pretty much of my presentation.
Thank you, Dr. Dai, for sharing your time and wisdom with the attendees today. Audience members, if you enjoyed today's session, please suggest it to a friend. Our next NSF Career Spotlight Series will showcase Dr. Hijun Zhu on April 13th at 12 p.m. Be sure to tune in and learn more about Dr. Zhu's research and how he prepared to submit his NSF career proposal. Interested in additional Office of Research and Innovation events? Please follow us on Instagram and Twitter and subscribe to our newsletter. Feel free to use your phone to scan the QR code on this slide or follow the links posted in the chat. Finally, please take a moment to complete our research event survey. We look forward to having you join us for a future Office of Research and Innovation event. Thank you and have a nice afternoon.
Thank you, everyone.